last video I showed you how to set up this chart with a small, medium, and large triangle and the short, medium, and hypotenuse sides to write a proportion to find missing sides in these overlapping right triangle problems. The only thing different in this video is they ask us to put our answer in simplified radical form, meaning we're not allowed to have decimals. Everything else though is going to be identical. So let's go ahead and start with our chart. If you don't like the chart, you're welcome to draw the triangles separately and try to write proportions that way, although I like using the chart. So here's my small triangle. I'm going to trace it out in red. This time I can see that y is the hypotenuse of that small triangle. It's across from the right angle. And 3 is the shortest side. If you can't tell which side is short and which side is medium, usually you can tell, but if you can't, my best idea is, well, just guess and see which one works. Sometimes one way won't work and another way will. So not probably the best advice, but it's what I do. Next up, I'm going to use the medium triangle, so I'll trace that out in green. This time it looks like at first glance I don't know anything about the medium triangle, but there is something I know. I know how long this side, the middle length, is, because since I know from the big triangle, from R to P that's a distance of 9, and R to S is a distance of 3, this must be 6 by doing some simple subtraction. So that is the medium length side of the medium triangle, so that's a 6. Now I may end up not even needing that number, but you know, I can find it, so I might as well get it in my chart. And then finally, let's look at the large triangle, which is the entire thing all together. So looking at that entire triangle, I can see that y is the short side, and that 9 is the hypotenuse. And this time I don't know the medium side, but that's probably going to be okay. So that's as much as I can fill in the chart. There's blank spaces, but that's totally fine. The proportion that I'm going to write is I'm going to match up 3 and y. So the first and third columns in my chart. So I want to find another spot where I can use the first and third columns, and that's down here. So I'm going to match up 3 over y equals y over 9 for my proportion. Okay? So here's where that simplified radical form is going to come into play for the no decimals. When I cross multiply this, y times y is not 2y, it's y squared. And then 3 times 9 is, of course, 27. So normally what we've been doing a lot this year is we've just been taking the square root of both sides, which is what we're going to do. But then, since this comes out to be a decimal, we've just been rounding. Well, simplified radical form means we do not round. In fact, we did this much earlier in the school year, and if you want to see a video about this, go back way to the beginning, and you should be able to find a video about how to simplify radicals. Otherwise, here's a real quick review of what we did. We said, let's break this number down into factors. And so two numbers that multiply to 27 are 9 and 3, and we keep factoring till we get to prime numbers. 3 is prime because you can't break it down any further, it's just 3 and 1, but 9 can break down to 3 and 3. And so what I'm looking for now is I'm looking for pairs of numbers in the primes. So there's a set of 3. Any pairs of numbers get to come outside of the square root, and then any single numbers are stuck inside the square root. So 3 is stuck inside. So there is my answer in simplified radical form. 3 square root of 3, no decimals needed. Again, if you want a more detailed review of how to find simplified radical form, search back in my videos and you should be able to find a video that talks about how to do this.